What you're about to witness is something that shouldn't be possible according to everything scientists thought they knew about glaciers. Right now, at this very moment, Alaska's glaciers are melting at a rate that has left climate scientists struggling to find adequate words to describe what they're observing. These ancient rivers of ice, some of which have existed for over 10,000 years, are disappearing before our eyes at a speed that defies conventional understanding. In the past 12 months alone, Alaska has lost more ice than it lost in the entire decade of the 1990s. More than an entire decade, in just 1 year. The Columbia Glacier, one of Alaska's largest, has retreated over 12 miles since 1980. But here's what's terrifying. Half of that retreat has happened in just the last 7 years. Scientists who have dedicated their entire careers to studying these glaciers are using phrases they never thought they'd have to use. Unprecedented melt rates, accelerating beyond predictions, and most disturbing of all, this defies all logic. I'm about to show you evidence that will fundamentally change how you think about climate change. Data that suggests we may have already crossed critical tipping points. And information that raises a question nobody wants to confront. Is it already too late to save Alaska's glaciers? Stay with me. Because what's happening in Alaska isn't just about ice. It's about sea levels rising faster than predicted. It's about coastal cities around the world facing an existential threat. It's about a planet that's changing faster than we can adapt. Let's start with what's actually happening on the ground in Alaska right now. Over the past 18 months, scientists monitoring Alaska's glaciers have documented changes that have fundamentally challenged everything we thought we understood about how ice sheets respond to warming. The Mendenhall Glacier near Juneau has retreated so rapidly that areas that were under hundreds of feet of ice just 5 years ago are now exposed land. Not gradually exposed over decades, exposed in 5 years. Dr. Jason Wright, a glaciologist with the U.S. Geological Survey who has studied Alaska glaciers for over 25 years, told reporters last month, "I've been coming to these glaciers since 1998. Every year I see changes. But what I'm witnessing now is categorically different. The speed of retreat, the volume of ice loss, the way entire sections of glacier are just collapsing. This shouldn't be happening this fast. This shouldn't be happening this fast." The Hubbard Glacier, one of the few Alaska glaciers that was actually advancing for decades, has suddenly reversed course. After years of bucking the trend and growing, it's now retreating rapidly. Scientists who expected it to remain stable for at least another 50 years are watching it shrink in real time. Dr. Sarah Martinez, a climate scientist at the University of Alaska Fairbanks, describes, "What they're seeing, Hubbard was our anomaly, our example that not all glaciers respond the same way. Its sudden shift to rapid retreat suggests that we've crossed some kind of threshold. When even the most stable glaciers start collapsing, it tells us something fundamental has changed in the system. Something fundamental has changed in the system. But it's not just the retreat that's alarming. It's how the glaciers are melting. Scientists are observing melt patterns they've never documented before. Enormous meltwater lakes are forming on top of glaciers. These lakes absorb sunlight, warming the ice underneath, which causes more melting, which creates larger lakes. It's a feedback loop that accelerates the process exponentially. On the surface of the Malaspina Glacier, one of the largest Piedmont glaciers in the world, satellite imagery shows over 200 meltwater lakes that didn't exist a decade ago. Some of these lakes are over a mile across. Dr. Michael Chen, who analyzes satellite data for NASA, explains, "These supraglacial lakes are acting like heat sponges. Dark water absorbs significantly more solar radiation than white ice. We're seeing lakes warm to temperatures over 60 degrees Fahrenheit in summer. That warm water is drilling down through the ice, creating vertical shafts that destabilize the entire glacier structure. The entire glacier structure is being destabilized from within. But there's something even more concerning happening below the surface. Sent submarine surveys of tidewater glaciers, those that flow directly into the ocean, have revealed that they're melting far faster at their base than at their surface. Warm ocean water flowing beneath these glaciers is eroding them from underneath. It's like they're standing on a foundation that's being eaten away. And when that foundation fails, enormous sections of ice collapse into the ocean all at once. These collapse events are becoming more frequent and more massive. In June of last year, a section of the LeConte Glacier calved off in a single event that created waves large enough to damage boats over 3 miles away. Local fishing boat captain described it, "I've seen calvings before, but this was different. It was like the entire face of the glacier just exploded into the water. The sound was like continuous thunder for 5 straight minutes. The wave it created was 12 to 15 feet high when it reached us. We barely had time to turn into it. Scientists estimate that single event released more ice into the ocean than the glacier had calved in the previous entire year. ND. These events are happening more and more frequently. Dr. Wright and his team have documented a 340% increase in major calving events over the past decade compared to the previous decade, BR, a 340% increase. In just 10 years. Oh, understand how shocking this is. You need to understand what Alaska's glaciers have meant throughout human history. Alaska contains approximately 100,000 glaciers. That's not a typo. 100,000. They cover nearly 5% of Alaska's total land area. These glaciers represent the largest concentration of glacial ice in North America. For thousands of years, these glaciers have been remarkably stable. They've advanced and retreated cyclically with natural climate variations, but the overall system remained in balance. Indigenous peoples of Alaska, the Tlingit, Haida, Athabascan, and others, have lived in harmony with these glaciers for millennia. Their oral histories speak of glaciers as permanent features of the landscape, as reliable as the mountains themselves. When European explorers first mapped Alaska in the 1700s and 1800s, they documented the positions of major glaciers. Those maps remained accurate for over 200 years. The glaciers were where the explorers said they would be, give or take minor variations. In the early 1900s, during the Klondike Gold Rush, prospectors used glaciers as landmarks for navigation. Many of those landmarks still existed in roughly the same positions into the 1980s and 1990s, but something fundamental shifted around the year 2000. The rate of glacier retreat, which had been relatively modest through most of the 20th century, suddenly accelerated. Between 1950 and 2000, Alaska's glaciers lost an average of about 20 gigatons of ice per year. That's 20 billion tons, which sounds like a lot until you hear this: between 2000 and 2020, that are tripled to nearly 70 gigatons per year. And since 2020, it's accelerated even further. Preliminary data from 2024 suggests Alaska lost over 90 gigatons of ice in that year alone. Dr. Martinez explains what this means. We're not seeing linear change anymore. We're seeing exponential acceleration. The rate of ice loss isn't just increasing. The rate of increase is increasing. That's what's so terrifying about the current data. We're watching a system spiral out of control. A system spiraling out of control. Historical photographs tell the story better than words ever could. There's a famous photo of the Muir Glacier taken in 1941 by a prominent photographer. The glacier filled the entire valley, a massive river of ice stretching as far as the eye could see. In 2004, scientists returned to the exact same spot and took a photograph from the same angle. The glacier had retreated significantly, but it was still recognizable as a glacier. Last year, in 2024, they took another photo from that same location. The glacier is barely visible in the distance, just a small tongue of ice at the end of a long valley filled with water and exposed rock. In 83 years, one of Alaska's most iconic glaciers has virtually disappeared. And it's not just Muir. The same story is repeating across Alaska. The Toboggan Glacier, the Northwestern Glacier, the Yale Glacier, the McCarty Glacier, all of them shrinking at rates that have shocked even the scientists who predicted they would LD shrink. One researcher, looking at before and after images, said something that stuck with me. I knew intellectually that climate change was happening. I'd seen the data. But seeing these images, seeing the same landscape completely transformed within a human lifetime, within my lifetime, that made it real in a way the data never did. So what's causing this catastrophic melt? The answer is more complex and more disturbing than most people realize. The obvious culprit is rising temperatures. Alaska has warmed faster than almost anywhere else on Earth. The average temperature in Alaska has increased by approximately 3 degrees Fahrenheit since the 1950s. 3 degrees might not sound like much, but for ice, it's everything. Glaciers exist in a delicate balance. Snowfall in winter builds them up. Melting in summer reduces them. When that balance shifts even slightly, the effects compound over time. But Alaska has experienced more than a slight shift. Summer temperatures in Alaska are now regularly reaching levels that would have been considered extreme outliers just 30 years ago. In the summer of 2019, Anchorage, Alaska hit 90 degrees Fahrenheit, 90 degrees in Alaska. That was hotter than New York City that same day. Dr. Chen explains how temperature changes impact glaciers. People think glaciers melt when temperatures go above 32 degrees Fahrenheit, the freezing point of water. But that's oversimplified. What matters is cumulative heat exposure. How many hours per day is the ice above freezing? How many days per summer? The difference between a summer average of 50 degrees versus 55 degrees is enormous in terms of total melt, and Alaska isn't just seeing slightly warmer summers, it's seeing dramatically warmer summers that last longer. The melt season, the period when temperatures consistently stay above freezing, has extended by nearly 3 weeks over the past 40 years. 3 additional weeks of melting every single year adds up catastrophically over time. But temperature alone doesn't explain everything. There's a second factor that's equally important and more insidious: rainfall. Alaska is experiencing a dramatic increase in rainfall, particularly rain-on-snow events. When it rains on snow and ice instead of snowing, the water percolates down through the snowpack, warming and weakening it. This accelerates melting far more than temperature alone would predict. One particularly devastating rain event occurred in December 2023. Normally, December in Alaska is deep winter, well below freezing. But in 2023, a warm atmospheric river brought heavy rain to many Alaska glaciers. The rain, hitting cold snow and ice, released enormous amounts of energy as it froze, heating the surrounding ice like a furnace from within. Dr. Wright estimates that single rain event caused more melting than an entire typical summer would have caused. We're seeing weather patterns that have no precedent in the observational rec. Dr. Wright explained, Alaska glaciers evolved to handle cold and snow. They're not adapted to handle rain in winter. It's like they're being attacked by something they have no defense against. The third factor is ocean warming. This is the one most people don't know about, and it might be the most dangerous. The Gulf of Alaska has warmed by over 2 degrees Fahrenheit in just the past 30 years. That warming water is flowing beneath tidewater glaciers, melting them from below at rates far exceeding surface melting. Submarine robots equipped with sensors have measured water temperatures over 45 degrees Fahrenheit at the base of some glaciers. That might not sound warm to you, but for ice sitting in that water, it's catastrophic. Dr. Martinez describes it: imagine holding an ice cube under lukewarm water from your tap versus in cold water. The lukewarm water melts it dramatically faster. That's what's happening at the base of these glaciers. The ocean is like a warm bath slowly dissolving their foundations. When the base of a glacier melts faster than the top, the entire structure becomes unstable. The glacier develops crevasses, weaknesses, and eventually enormous sections break off in catastrophic collapse events. The fourth factor, and perhaps the most alarming, is what scientists call positive feedback loops. Once melting starts, it creates conditions that accelerate more melting. When ice melts, it exposes darker rock and soil underneath. Dark surfaces absorb more sunlight than white ice, heating up the area, which causes more melting. When meltwater flows across a glacier's surface, it creates channels that absorb more heat, causing more melting. It's like a snowball effect, except instead of growing, the snowball is disappearing and the rate of disappearance keeps accelerating. Dr. Chen puts it bluntly. We've triggered feedback loops that are now operating independently of current conditions. Even if we could magically stop all human carbon emissions tomorrow, these glaciers would continue melting for decades because the feedbacks are already in motion. We've set something in motion that we can't easily stop. We've set something in motion that we can't easily stop. Let me show you what this looks like for the people who live in Alaska and depend on these glaciers. In the small community of Yakutat, population around 600 people, the local economy has revolved around fishing and glacier tourism for generations. The Hubbard Glacier has been the main attraction, drawing thousands of tourists every year. But as the glacier has retreated and become less stable, tour operators have had to move their boats further from the glacier face for safety. Chunks of ice, the size of buildings, can calve off without warning, creating dangerous waves. One tour operator told a reporter, "My grandfather ran these tours. My father ran these tours. I've run them for 23 years. But I'm not sure I'll be able to pass this business to my DS." The glacier isn't just smaller, it's less predictable, more dangerous, and tourists are starting to notice that what they see doesn't match the photographs in the brochures. The community's economy is slowly dying along with the glacier. In southeast Alaska, several native villages are facing a different crisis. These communities have depended on salmon for thousands of years. But salmon depend on cold, clean water flowing from glaciers. As glaciers melt and disappear, the streams they feed are changing. Some are drying up in late summer. Others are becoming too warm for salmon to spawn successfully. The entire ecosystem that has sustained these communities is unraveling. Martha Johnson, an elder in one of these villages, explained, "My people have caught salmon in this river since time beyond memory. My grandmother's grandmother caught salmon here. But in the past 5 years, the runs have gotten smaller and smaller. The water isn't right anymore. It's too warm, too low in the late summer. The young people are leaving because there's no future here. There's no future here." Think about what that means. An entire way of life, thousands of years old, ending within a single generation. The glacier melt is also causing dangerous floods. When glaciers melt rapidly, they can create outburst floods called yokolaps. These occur when meltwater trapped beneath or within a glacier suddenly breaks free, releasing millions of gallons of water in a catastrophic flood. In August 2023, an outburst flood from the Mendenhall Glacier devastated parts of Juneau. The flood destroyed over 100 homes, washed away roads and bridges, and caused over $100 million in damage. Residents described it as a wall of water appearing without warning in the middle of the night. People had minutes to evacuate. Some lost everything they owned. And scientists warn these outburst floods will become more common as glaciers continue to destabilize. Communities that have been safe for centuries are now in danger zones. Infrastructure built to withstand normal conditions is failing. Roads built on permafrost are collapsing as the ground beneath them thaws. This thawing is accelerated by the loss of nearby glaciers, which used to keep the surrounding area cooler. The Alaska Department of Transportation estimates that climate-related damage to roads and infrastructure is costing over $300 million per year, and that number is climbing. One highway engineer explained, "We built this infrastructure assuming certain stable conditions, cold temperatures, frozen ground, predictable snowfall. All those assumptions are now invalid. We're trying to maintain systems that were designed for a climate that no longer exists. Trying to maintain systems designed for a climate that no longer exists. Now, I need to tell you about something that doesn't get discussed enough. The global implications of Alaska's glacier melt. Alaska's glaciers contain enough ice to raise global sea levels by approximately half an inch if they melted completely. Half an inch might not sound like much, but consider this. Over 600 million people live in coastal areas less than 30 feet above sea level. Even small increases in sea level have massive consequences. A 6-inch rise in sea level doesn't just mean the water comes 6 inches higher. It means storm surges reach further inland. It means high tides flood areas that were previously safe. It means salt water intrudes into freshwater aquifers. But Alaska's glaciers aren't melting in isolation. They're part of a global system. As Alaska's glaciers disappear, they contribute to accelerating ice loss elsewhere. The cold meltwater flowing into the ocean from Alaska's glaciers affects ocean currents. These currents help regulate global climate. Disrupt them, and you create changes that cascade across the entire planet. Dr. Martinez explains, people think of Alaska as remote, disconnected from the rest of the world. But the ocean is a connected system. What happens in Alaska affects ocean temperatures, salinity, and currents that influence weather patterns globally. The moisture that falls as rain in the Midwest can be traced back to evaporation in the North Pacific. The jet stream patterns that determine where storms form are influenced by temperature gradients that are changing because of Arctic ice loss. It's all connected. It's all connected. There's also the issue of timing and acceleration. Current IPCC climate mode, LS predicted that Alaska would lose a certain amount of ice by 2050. But Alaska has already lost more than those models predicted. And we're only in 2025. Dr. Wright points out, when reality is outpacing our models, that's a warning sign. It means we don't fully understand the system. It means there are feedback mechanisms or tipping points we haven't accounted for. And it means the future could be worse than we've predicted. The future could be worse than we've predicted. Some scientists believe we may have already crossed irreversible tipping points. Dr. Chen suggests there's growing evidence that certain thresholds, once crossed, can't be uncrossed simply by reducing emissions. The ice albedo feedback, where melting ice exposes dark surfaces that absorb more heat, may have already locked in decades of additional melting regardless of what we do now. Locked in. Regardless of what we do now. That's a terrifying concept. The idea that we've already set in motion changes that will continue for decades, maybe centuries, even if we take aggressive action today. Let's talk about what the scientists studying this are saying privately, because what they say publicly is often carefully measured to avoid accusations of alarmism. One glaciologist, speaking to colleagues at a private conference, said, "We're watching these glaciers die. That's not hyperbole. Within my lifetime, glaciers that have existed for 10,000 years will be completely gone." And I don't think the public understands what that means. These aren't just scenic features. They're critical components of Earth's climate system. Another researcher in a leaked email wrote, "I'm tired of softening my language to make the data more palatable. The glaciers are collapsing. The rate of collapse is accelerating. If current trends continue, most of Alaska's glaciers will be functionally extinct by 2100. We need to stop pretending this is manageable. Functionally extinct by 2100. That's less than 80 years away. Well within the lifetime of children being born today." A third scientist told a journalist off the record, "My colleagues and I increasingly feel like we're documenting an extinction event in real time. We publish papers. We present data. We warn policymakers. And the glaciers keep melting faster than we predicted. At some point, you have to accept that what you're studying isn't going to survive. What you're studying isn't going to survive." These are people who have dedicated their lives to understanding glaciers. and they're watching helplessly as their life's work literally melts away. There's a psychological toll on scientists working this field. Some have described it as chronic grief. You form a relationship with these landscapes you study, you spend years, sometimes decades, working in the same locations, and then you watch them disappear. Dr. Wright admitted in an interview, "I fell in love with glaciers when I was 22 years old on my first research expeditio. I've spent 30 years studying them, and now I'm watching them die." It's not just an intellectual loss, it's personal. These places have meaning to me, and I'm powerless to save them. The human cost of scientific observation. Watching something you love disappear and being unable to stop it. But beyond the emotional toll on scientists, what about the rest of us? What does this mean for people who don't live in Alaska, who have never seen a glacier? The answer is sobering. Alaska's glaciers are like the proverbial canary in the coal mine. They're an early warning system showing us what's coming for the rest of the planet. What's happening in Alaska today will happen in other regions tomorrow. The glaciers of Greenland, Antarctica, the Himalayas, the Andes, they're all facing similar pressures. And as they melt, the consequences compound. Sea level rise will accelerate. Coastal cities will face increasing flood risks. Fresh water supplies will be threatened as glaciers that feed major rivers disappear. Climate patterns will shift in unpredictable ways. The World Bank estimates that climate change could force over 140 million people to migrate by 2050. Many of those migrations will be driven by sea level rise and water scarcity, both directly linked to glacier melt. We're not just losing ice. We're losing the stability of systems that billions of people depend on. Dr. Martinez puts it in stark terms. Alaska's glaciers are showing us our future. A future where landscapes we thought were permanent change within a human lifetime. Where infrastructure built for one climate fails in another. Where communities that existed for thousands of years can no longer survive. That's not just Alaska's future. That's the world's future if we don't take dramatic action. So where does this leave us? Alaska's glaciers are melting faster than any scientific model predicted. The rate of melt is accelerating, not stabilizing. Feedback loops are amplifying the problem beyond our ability to easily control it. Scientists who have spent their careers studying these systems are using words like unprecedented, alarming, and defying logic to describe what they're observing. Can we save Alaska's glaciers? The honest answer is probably not all of them. Some have likely crossed irreversible tipping points. They will continue to melt and eventually disappear regardless of what actions we take now. But we might be able to slow the rate of loss. We might be able to save some glaciers if we take aggressive action on climate change, dramatically reduce greenhouse gas emissions, transition to renewable energy, protect and restore natural carbon sinks like forests and wetlands. Dr. Chen is cautiously optimistic. It's not too late to make a difference. The glaciers we can't save, well, they're already doomed. But there are glaciers that are still relatively stable. If we act quickly and decisively, we might preserve some of them. But quick and decisive action means we need to start yesterday. Every year we delay, more glaciers cross the point of no return. Every year we delay, more glaciers cross the point of no return. The science is clear. The evidence is overwhelming. Alaska's glaciers are in crisis. They're melting at rates that defy conventional understanding. And their fate is intimately connected to our collective future. We're watching ancient ice that fell as snow when humans were still living in small hunter-gatherer bands, disappear in the span of a few decades. Ice that was already ancient when the pyramids were built. Gone in a geological eye blink. If you found this information important, hit that subscribe button. Share this video with people who need to understand what's happening, because this isn't just about Alaska. This is about the planet we're leaving to the next generation. Alaska's glaciers are melting at an alarming rate. They're defying the logic of what we thought was possible. And the scientists studying them are running out of ways to communicate the urgency of what they're witnessing. The ice that has shaped Alaska's landscape for 10,000 years is disappearing, and once it's gone, it won't come back. Not in our lifetimes. Not in our children's lifetimes. Not for thousands of years, if ever. We're living through a transformation of our planet that future generations will study in history books. They'll look back at this moment and ask, what did they do when they realized what was happening? What will your answer be?